Hi everyone, welcome to my channel. Today I will teach you the chapter hydrogen. Okay, so today the first element, okay, so the first element in the periodic table is hydrogen. It belongs to the first group and the first period of the periodic table. It looks like this hydrogen 1 1 where it has got number of proton also 1, electron also 1 and neutron is 0. Also, hydrogen has got 3 isotopes 1 1, 2 1, 3 1. Isotopes where there are equal number of atomic number while different number of mass number or different mass number and similar atomic number. So the number of neutrons are going to be different in this case. Okay. Note that hydrogen shows dual nature since it resembles the alkali metals of group 1A and halogens of group 7A. Now we will check the similarity that it has with the alkali metal and the halogens separately. So basically this means that in the periodic table it has got two different positions. 1A also contains hydrogen as the first element. In 7A also hydrogen is present as the first element. Why is it so? Why is it given two different positions? Similarity between hydrogen and alkali metal. Electronic configuration. Only one electron in the outermost shell, as I have shown just now that it has got one electron. So it has got one shell only and one electron in it, which is exactly similar to the alkali metal which has got one electron in the outermost shell. For example, sodium, it has got electronic configuration 281. It also has got only one electron. All the elements that belong to that particular group have got similar number of valence shell electron. Next, all elements have got only one electron in the outermost orbit. Yes, same as this. Outermost shell or the valence electron is 1. Ion formation, they can form positive ion. How? Hydrogen can lose one electron and form H+, similar to sodium which can lose one electron and form Na+. Correct? Good enough. Next, reducing power. Now, reduction tendency for hydrogen is the highest. Whenever we talk about reduction, it means hydrogenation only, means addition of hydrogen is reduction. In this reaction C, CuO, we are adding hydrogen, it forms Cu plus H2O. This is reduced condition, reducing power. It is reducing copper oxide to copper. Similarly, sodium can also get added to a system and form like this. Oxide will be Na2O and copper will be left as the only element. So it is possible in this case as well. So similar property with that of the alkali metals. Burning. Hydrogen burns in oxygen to form water. Li also form Li2O. Sodium also forms sodium peroxide. H2O2 is also possible to form H2O2. That's a peroxide version of hydrogen. So these are quite similar property between hydrogen and alkali. In this way, if we go and check with the halogens, there also one electron less than the nearest noble gas. Hydrogen can accept one electron and form H minus, which is a stable electronic configuration, that is 2 in the first shell. It is possible to form that. The other element in that particular group also can form stable ion like Cl minus, F minus, Br minus, I minus. Halogens are what? Fluorine, chlorine, bromine, iodine. Above that, hydrogen is present. So these also have similar property. They also want to accept one more electron and form anion. So formation of ion is also the same formation of anions. Electronegative character. Both the halogen and hydrogen are non-metal. Although it is placed along with the metals, but hydrogen is actually a non-metal. It's a gaseous non-metal. It shows one electron in the outermost shell and it also have got electronegative character like the halogens, which is obviously very electronegative. Fluorine, chlorine will accept electron like 2 very much. Hydrogen not that much, but yes, it has got a tendency to form anion, that is H minus. Physical state, halogen is hydrogen, which is a gas. Exist in form of diatomic molecule H2, just like Cl2, Cl2, Br2, they are also gas. Hydrogen also exists in that state. Now, is it so that all the properties are same? No. There are some dissimilarities as well. But Because of this similarity only, it is placed along with the halogens in the and the alkali metals in the periodic table. Hydrogen was first discovered by Henry Cavendish. It is called inflammable air because of its combustible nature, which means it will burn. It is going to burn in presence of air. Its ability to form water, that Lavoisier named it hydrogen. Hydro, the word hydro means, just a second. The word hydro means water and gen means water former. Okay. So water former is hydrogen. From hydrogen we can get water, H2O. So it is hydrogen, named like that. Now some reactions of hydrogen in presence of water. Some reactions of formation of hydrogen in presence of water. Reactive metals, sodium, potassium, calcium, which is present exactly at the beginning of the electrochemical series. First it will be potassium, sodium, calcium, magnesium, aluminium, zinc, iron and so on. Lead, then comes hydrogen. Okay, Pb, then hydrogen, below that copper. So hydrogen is quite below. So hydrogen can easily be formed from these metals. These are very reactive, hence they can easily liberate hydrogen in presence of cold water. Just they need cold water and hydrogen will be formed because the reaction is very much explosive. So vigorously reaction will take place and hydrogen will be formed. Reaction of hot water and steam on metal. Now, since we are moving down the electrochemical series, activity series, magnesium, aluminum, zinc, they are less powerful. Now they need something which is having greater power. So, magnesium, aluminum, these are powerful. I mean less powerful, but water has to be not in the original temperature, not cold water. It has to be hot water or steam, which is more reactive and hence hydrogen will be formed easily from it. So MgOH whole 2 plus H2, Al2O3. Now see, hydroxide formation decreases. MgO forms or MgO, MgOH whole 2 or MgO. Now here see oxides, no more hydroxide. Okay, along with that, hydrogen gas is formed. Zn plus H2 or ZnO plus H2, steam on metals. Steam will act on these metal. And finally, steam here acts in presence of iron and the reaction is reversible. Please remember this answer. This is the only metal which reacts with steam to produce hydrogen gas. This question is very important for class 8, 9, 10, all the classes. This reaction itself is very important. It's the only reversible reaction. All others are not. Metal activity series. So this is the series I have shown. Arrangement of the metal in decreasing order of reactivity in form of a series is known as activity or reactivity series of metals. Features of the series: electropositive character decreases down the group. Whenever you are moving down the group, the electropositivity decreases. Most electropositive nature is potassium, sodium, calcium, just above, very much above. Reducing power of the metal decreases down the group. Reducing power means reducing someone else and itself getting oxidized. That power decreases. Reducing power of the metal decreases down the group when you're moving down the group. Tendency of the metal to lose electron decreases. See, these are the ones which are electropositive in nature. Electropositive character decreases down the group. So, electropositive power high means they have more power to lose electron. This point and this point is almost similar. Whoever is below the series will have less electropositive character. So it is not going to lose electron that easily also because it is not electropositive. So losing of electron below the series will decrease. Metals above hydrogen displace hydrogen from water. Above series, hydrogen will get displaced to form water. And dilute acid, but metal above hydrogen do not. Okay, this is a very important point. From here I can explain you a question as well. Okay, see. Metals above hydrogen from water and dilute acid, but metals above hydrogen do not. What happens? See, if I take two metal, for example, magnesium plus water, and below that, above that, calcium, potassium, or let's take potassium plus water and iron plus water. This reaction is more vigorous, means formation of hydrogen in this case will take less time and will form rapidly compared to this hydrogen production. Here also we will get oxide Fe3O4, here we will get hydroxide, but hydrogen formation in this case will be quite fast. Because it is present above the series, its power to displace hydrogen will be faster. Larger the difference in position of the metal in the activity series, more rapidly the displacement occurs. Difference in the position of the metal in the series. When there is a series of metal, greater the difference in the position of the metal, more rapidly the displacement occurs. So the displacement is faster in this case because hydrogen and potassium is quite placed, they have got a quite gap in between them. However, iron and hydrogen is placed closer to each other. Hence, this fact is happening. Okay. Important reactions. Okay. Let's see some reaction from where hydrogen can be formed. Na plus H2O, NaOH plus H2. Copper plus H2O, no reaction. CuSO4 plus Zn, okay. Later on, let's see. Cu plus H2O, no reaction. Why? Because hydrogen, copper is placed below hydrogen in the series. Below hydrogen in the series, copper is present. That's why it is not easy to displace hydrogen. Below hydrogen, if someone is there, it is not having the power to displace hydrogen. Whoever is present above will displace hydrogen. Understand this point very carefully. If someone is present above the metal activity series, then they can displace the one below it. But if someone is present below one element, they can't be displaced. Hydrogen is present above, copper is below, so you cannot displace this from this. You cannot form hydrogen from copper. However, this is present above, so they can displace the one present below it. Larger the difference in position of the metal in the activity series, rapidly the displacement occurs. Just the one previously. Larger the difference. See, this is another example where no hydrogen is involved, but the reaction is similar. CuSO4 plus Zn. Cu is present below Zn. So, CuSO4 plus Zn, forming ZnSO4 plus Cu is not that rapid. This reaction is not favorable. This is not a favorable reaction because copper is present below. However, zinc is present. Okay, no, sorry. I'm sorry. This reaction is feasible. This is feasible because copper is present below. Hydrogen is present above. So, it is possible to displace it. Yes, it is. It is. My mistake. Sorry. Once again, let's check the series. It is potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, and then comes copper. Iron, lead, hydrogen, then copper. So zinc is present above, copper is present below. So displacing copper is easier. So this reaction is possible for zinc. Zinc can react with CuSO4 to form Cu. However, the opposite reaction is not possible. Cu plus ZnSO4 is not possible because copper is present below. So it cannot undergo reaction and form the one that is present above it. Okay. So whoever is present below can be displaced and can be formed. Okay. Done. Next. Mg plus HCl, MgCl2 plus H2, Al plus, these are some acid which reacts with active metal. These are active metals. See, all are metals. Mg, Al, Zn, Fe, all are metals which react with acid. All these are acid. Till here, these are all acids. All will form corresponding salt and hydrogen gas. Hydrogen, because all these cases contain hydrogen. And hydrogen will easily be displaced. Very easy reaction. Very easily these reactions happen. Now, coming to alkalis. These are alkali. Sodium hydroxide, potassium hydroxide are alkali. These will react with metal to form, these are the specific metal which will react with these alkali to form hydrogen. See, generally formation of hydrogen from acid is easier, but not from alkali. So you can see some common elements or common metal like zinc, lead can also react with acid, and aluminium. Aluminium, here also we have got aluminium. Lead can also form. For your ease, I'm writing down Pb plus HCl will form PbCl2 plus H2. It is possible to form this reaction. So we have got common metals which react both with acid as well as alkali to form hydrogen gas. These are known as amphoteric metals. So write down over here, amphoteric metals. Amphoteric metals reacts both with acid as well as alkali to form what? Hydrogen gas. So the metals will form hydrogen gas. Metal oxide will form water. If in this case we had metal oxide like ZNO, the answer would have been H2O. So if they ask you amphoteric metal, answer will be direct metal. If they ask you metal oxide, just add oxygen to them. That's it. So this point is very important. Oxides of metal are amphoteric and react with both acid and bases to give salt and water. Alkali and bases are almost similar. Alkalis are the one which are soluble in water. Like bases soluble in water are alkalis. Okay. That's it. This is the first part of hydrogen. I'll keep it till here. In the next part of this chapter, we will study about the laboratory preparation, industrial preparation, oxidation, reduction, and thereby the chapter will end. So, I hope you like this video. Thanks for watching.